My name's John Pitcher. I'm currently working as an applications engineer with A2K Technologies. I've been in this, thanks Ben for confirming that. And sorry, Dex, it looks like most people missed your intro there. So yeah, perhaps I'll give a bit of an outro at the end of the session there. So it seems an issue with Dexter's mic. So apologies for that. But yeah, just a little bit about myself first up. So my background is in the manufacturing sector. I've been working in manufacturing for about 20 odd years, including my time with A2K and in the Autodesk channel. But basically, I do quite a bit of the training for A2K Technologies around the Inventor product, and also AutoCAD and Fusion and a number of other Autodesk applications. As I mentioned, my background is in the manufacturing side of things. So I did an apprenticeship many years ago as a fitter and turner, and sort of specialized in the CNC side of things. For those of you that might know a little bit about CNC or computer numeric control programming of machine tools, etc. Also spent a bit of time in hydraulics and pneumatics and machine tool design and manufacture. But yeah, for about the last 14 years, I've been connected with the Autodesk line of products. So been working with various CAD CAM solutions over that time, and more recently been a bit involved in the additive manufacturing or 3D printing space. Not so much interested in printing trinkets and key rings and things like that, but more in actual physical products that are usable for people who are wanting to create a range of products that are actually useful in industry. And certainly using Fusion to do that has been really beneficial. There's some awesome little tools in Fusion that we'll talk about in a moment that that certainly will help you in your manufacturing processes. And really what we're here to talk about today, though, is some information with regard to data management and collaboration as far as the Fusion product is concerned. Now, Fusion itself is a really great little product. It's perhaps a slightly newer CAD system than many of the other systems you may have come across if you've ever worked with CATIA or Pro Engineer or Inventor or any of the other products out there in the marketplace. Fusion is certainly one of the newer products in that respect, in that it was, but we'll go a little bit more into that in a bit more detail shortly. So effectively, the concept of what we want to discuss today is all around this principle of the future of making things. And Autodesk have been talking about this for a number of years, and it's certainly not a new message, but it's a message that we think is very relevant to today's manufacturing, and certainly a valuable and important part of moving forward with engineering in many different disciplines, whether it be mechanical, electrical, civil, architectural, whatever space you're working in. I think we're going to see some really major changes, and look, Autodesk are at the forefront of a lot of this by creating products that are very interactive and much more collaborative in the way that they function compared to what we were doing even just 5 or 10 years ago or 20 years ago. So certainly some really good changes moving forward and happening in that space. So Fusion 360, a really powerful little CAD system. I tend to refer to it as the new kid on the block. It was developed sort of in the 90s and into the 2000s. It was first released in 1993 as a very basic online type tool. But what you've got to understand is that going back in the 90s, we were still working with dial-up internet and some other things like that, and certainly before that. So all the CAD systems that were developed prior to that time were developed as standalone packages, whereas what Autodesk have done with the Fusion product is, because they could see the internet revolution taking place and some really great beneficial options there for working with all sorts of elements of cloud-based computing, they embraced that and used Fusion as their platform to launch that into industry. So in the late 90s and early 2000s, obviously we saw a fairly major change to the way we started doing things. Most of us started to adopt things like NetBank and some of those other things into the 2000s and 2010 era. And we've seen massive changes in the way that we basically live our lives in the last 20 odd years. So the real important thing as far as CAD and CAM systems go with that regard is that we've got some really good tools that we can utilize and make use of as part of our manufacturing and design engineering processes. And some of those elements have massively changed since a lot of the CAD systems that were developed back in the 70s and 80s. So AutoCAD, which was first released in the late 70s, obviously didn't use internet at all. It was very much a standalone package. But as time's gone on, certainly CAD systems have started to utilize and to work with the system of cloud computing and internet adoption and collaboration. So that's what we hope to talk about today. And like I said, the future of making things is one of those things. It's quite an important shift, I suppose. And some of you may have heard of the thinking of Industry 4.0, which is what out in the big wide world they're calling the fourth industrial revolution as such. And I've actually done a webinar on that some time back. You might like to do a Google search, or I can send you the link to that if you'd like to know a little bit more about that. I did a brief overview of the industrial revolutions that we've seen and how they've affected the way that we make things effectively. And so how we're going to make things moving into the future is going to be vastly different. In actual fact, we're seeing a lot more connected design. We're seeing a lot more interactivity between processes and various elements and systems within our manufacturing space. And obviously, if we want to be designing in the next 5, 10, 20 years, we need to keep abreast of some of these changes, because if we were still doing what we did in the 70s, obviously there would be no continuous improvement or progression through that. So a lot of designers are now really having to rethink their methodologies and their systems. And really what we are needing is very agile systems, is what we tend to refer to now, to manage the rates of change that as designers and engineers we're needing to adapt to. And as I mentioned, one of the biggest changes that's affected global industry is the internet revolution and being able to utilize some of those things. The other thing that's changed massively is the amount of data that we consume and create as part of our engineering design element. And really that's where Fusion really shines. It becomes a very, very powerful system because it is so connected to the internet, and we're able to use that. And I'll be doing a demonstration a little later on to show you how we can leverage some of those tools within the Fusion system to make our designs communicate and work more appropriately for our system of things. So yeah, with the CAD industry, we've obviously over the years created a great deal of data, and a great deal of information is generated and utilized as part of doing things like FEA studies and thermal inspections and things like that are going to help us utilize some of those tools. So I'd like to talk a little bit about Fusion 360 first up, just for those of you that maybe aren't familiar with it. And I've got a couple of slides in a moment just to go through that. So Fusion 360 is a very interesting part of the Autodesk line of products. Some of you may have heard of the other Autodesk 360 tools. We've got AutoCAD 360 now, where we can actually use an online version of AutoCAD. We've got BIM 360, which is an online repository for architectural data or general data within a architectural type system. We've got Drive 360, which is another tool that Autodesk have released into the marketplace for utilizing CAD data within their CAD system. So a lot of these are a little bit like Dropbox, but sort of on steroids, I suppose, if you like, in that they link in with much of the other software that we might be using. So all of those tools are what we call cloud dependent tools. So AutoCAD 360 can't function unless you've got a good internet connection. So if you're in a gray area for internet connection, your AutoCAD 360 will struggle. The benefit with Fusion is that it's not so much cloud dependent, it's cloud enabled. So it functions as a locally installed piece of software, very powerful little piece of CAD software, might I say, but it means that we can save our files locally if we wish to. And I'll go through that when we get to our demo in a moment. But the cloud collaboration tools mean that we can share data very, very quickly and seamlessly with people in our team on their chosen device. Doesn't have to be a Windows device. We can share information across Mac and Windows type situations. And yeah, that's one of the very powerful aspects of Fusion, is that it can run natively on a Macintosh machine. So if you're a Mac user, you'll be pleased to hear that. We've got some really useful little tools for working with Mac operating systems. But just to go into a little bit more detail in the Fusion space itself, it's not just a CAD system. The Fusion software is much more involved than that, in the sense that it's a CAM workspace. So what we've got is a function to be able to create CNC data and toolpath information. We can use it for rendering and simulation. So we can do FEA studies, as I mentioned earlier, but all the data is kept in the one application. So we also have the ability to create sheet metal components. We can animate and explode assemblies. And also Fusion has a very, very powerful function and interface for working with T-splines and NURB surfaces for those of you that are doing more complex shape design. So yeah, as I mentioned before about the industrial revolutions, I've just got one slide on this. It's a bit of a pet subject of mine at the moment. I've been quite interested in the history of some of that, and I won't bore you to tears, but just for your information, this is what we consider the 4 industrial revolutions that have taken place over the last couple of centuries. So we've got here just industry 1.0, 2.0, 3.0, and as I said, in the current scenario, from about the late 70s, early 80s was when this sort of started to kick off, is what we call Industry 4.0. And like I said, the main thing with regard to the way that the engineering data is managed, we've got quite a lot of principles and concepts that have changed, and certainly the rate at which we're creating data and using information. And so Industry 4.0 really moves into the area of cyber physical systems, as they call it. And it's a much more interlinked and holistic approach to manufacturing. And it certainly connects physical and digital to allow for better collaboration and access between departments and partners. So we talk about removing silos of information and bringing them all together to boost productivity, improve processes, and to drive growth throughout our system. And this is something that Fusion does extremely well. And I'll be launching into a bit of a demonstration shortly, just to show you how we can utilize some of these tools. And really, at the end of the day, the concept of working with Fusion is that we can link all our data via the cloud and a cloud storage system, a bit like you would with Google Drive or Dropbox, but obviously this is specific to CAD systems. So we have some very nice tools for doing markups and different things like that. So quite a massive leap forward, I suppose, from the type of CAD that we were using, even say in 2010 or 2005. There's been a lot of changes in the last 10 to 15 years that that have made big leaps forward for us in being able to collaborate and work with that. So what we have in Fusion is this, what we call the Fusion data panel, which is effectively a link to, much like you would have with your net banking system, where we can go and do shares and other aspects of net banking. But the real benefit of this is that it's linked to predominantly CAD data, but can be used for any data. It's not specific and limited to data in that sense. So yeah, what I'd like to do is just jump into a bit of a demonstration now and step you through a couple of little points with regard to Fusion. Fusion is an extremely powerful tool that allows us to certainly utilize many other elements of the cloud interface and working with that. And look, I think it's here to stay. The whole concept of working with the cloud, as I said, not too many of us nowadays don't use NetBank, and some of those other internet-based tools for, yeah, maybe managing your share portfolio or whatever it might be. So certainly it makes sense to work with that. So I've listed a couple of things there with regard to accessing files from any device, and certainly some of the data securities. A lot of people are a little bit concerned about their CAD data being available to other people. Autodesk do have numerous standards for that. There is a data security standard, ISO 270018, as you can see on the screen there. And Autodesk do tick a number of boxes that allow us to see how that particular system works. But what I'd like to do now is swing over to Fusion and give you a bit of a look at how the Fusion interface behaves and some of the different areas of that. So this is my Fusion window, and I should just say, if you've got any questions, please do feel free to pop them into the chat window, and I'll endeavour to answer them at the end of the webinar, or if you'd we'll have a bit of an open forum at the end of the session here. So if you if you'd like to sort of understand some more things about this, A2K is certainly happy to help and give you some pointers here. But basically, I've got a very simple vice open on screen here. That's just a very basic assembly that we might utilize and work within in Fusion 360. As you can see, it's just a very simple little vice. It does have numerous components to it, or a number of components there, and I'll certainly be stepping you through a couple of elements for that. But the main thing that I'd like to just explain, as you can see, we've got sort of a fairly typical ribbon menu across the top here. We've got some feature tree type informations down here, and down on the bottom left, we've got a very important part of Fusion called the timeline, which is the history of how this assembly came about. And look, I've covered numerous other of these in different webinars. I've done quite a number of Fusion webinars about part modeling and assembly modeling and drawing design and different things. So you might like to have a look for some of those, or I can share the links to those webinars that we've done over the last number of months with regard to Fusion specifically. But as I mentioned, this little button in the very top left is a very important part of our Fusion area. This is what we commonly refer to as the data panel. Okay, now the data panel is basically a window into your cloud storage area. And in this area, we can set up multiple projects. So we can have a whole bunch of different projects that we might use, different items. And inside each of these items, we might have, particular areas of design. So I've got a number of files here that I've used over the years for various aspects of working with that. And this particular design that you can see on the screen at the moment is this particular item here. So the vice assembly you can see down here. Now, the really cool thing about Fusion is we don't need to worry too much about release management, because Fusion actually remembers each save that we do. So you can see that I opened this file roughly 50 minutes ago, and effectively I did a save on that particular file, and I can actually go in and explore some other information about this. We can create a milestone. We can do quite a lot of cloud-based information. So you can see that I created this back on the 11th of October last year, around midday, and effectively we can see when that particular file was saved. I also saved it at 1:52 that same afternoon, and we can see all of that history of how our file was actually created. So you can see in here, we can see if we've got other components, or these are all the components that are used inside of that particular assembly. And under here, you'll see that if I had a drawing, for instance, or if I'd put this particular vice onto a machine tool, it would show me that it was linked to that particular item inside of my Fusion system. Now, this particular one doesn't have a drawing. I actually think I have got a drawing under this folder here. Maybe I'll just have a quick look under this particular folder. Yeah, so here's a drawing that I created of this same vise some time ago. And again, you'll notice that so just some working drawings of that. I also created an exploded view down here of my vise. But if I was to go and open this particular drawing file, again, this one was saved back in September of 2021. And hopefully this is going to behave and my internet will hold up here. But yeah, effectively, this is just opening that drawing file. But you can see all the history here, which is all kept in a cloud type storage system. So here's a very basic drawing of my vise item. And again, some of those different. In actual fact, I've got a number of sheets that I've done here to detail some other elements of my vise. And look, if you would like to know more about using Fusion in this regard, certainly, yeah, like I said, have a bit of a look, or we can, I'm sure Dexter and I can share with you some of the links for some of the other webinars that we've done over the years. So this is basically, like I said, this data panel on the left side is your window into the cloud storage space of your Fusion software. Okay, quite easy to use. As you can see, like I said, I've created a number of projects over the years that I've used for various aspects of yeah, training or whatever it might be. And you can see down here, I've got those projects all stored in the cloud. So I could go and fire up a computer in Sydney, log on to my Fusion 360 account and have access to all of these designs. Now, as you might have noticed, if I go into one of these projects, up the top here, we've got two headings. We've got data and people. So data is obviously all of my drawing files, my particular drawings and things like that. If I was, for instance, to go over here, and I'm just going to do a quick little demonstration. If I was, for instance, to share this this particular design with one of my colleagues who, sorry, you missed hearing Dexter this morning. He was doing an introduction. But if I invite Dexter to have a look at this particular project, Dexter will get an email to say that John Pitcher has shared with you the design. Would you like to go and view that? And as you can see, I'm the moderator or the owner of the data. But down here, I've just simply shared this with my colleague Dexter. So what happens in the background is that Dexter will receive an email, and I'll just get Dexter to forward that on to me, and I'll be able to show you that email. Just give me 2 seconds. So while basically what this has done is given Dexter access to view the file. Now, as the moderator for this particular project, I can also give Dexter the option, for instance, to edit the files. So we can collaborate quite quickly with people all around the world. Obviously, this is just based on an email address, and basically an email will pop up. Oh, yeah, thanks, Dex. I can see that's come back in. So yeah, basically Dexter receives an email to say that I have emailed him a link to my particular drive for the A2K Fusion 360 training project, and that he can go and link to this and go and have a look and be able to have input into that design process. So an email is sent to anybody that we include in the project, and they are able to be able to be involved in that at whatever level I allow that person to be. So effectively, we can quite quickly and easily include and collaborate with other users. And to remove Dexter from that, I simply move up here and remove Dexter from the project, and Dexter will no longer have access. Okay, so it's as simple as that, a matter of just popping email addresses in here to share the various information with various users. And like I said, we can set up permissions and give different people levels of permission for working with the Fusion data that they might be able to either see or edit. So we can set up all sorts of permissions and areas for working with that. So that's one of the little collaboration tools. Now, Your Fusion automatically links into what we call A360 Drive, which is the Autodesk system that is basically collaborating and storing your data. So the drive system within Autodesk system is very, very powerful. It basically is remembering all this data and understanding that. So we could go through and open this up as a file and work with that on Dexter's login. So Dexter could simply go and log in as well. So that's a very basic look at what we can do by way of collaboration. And that's just one little part of working with other people within your organization to very quickly and easily, no need to email files across anymore, because Dexter now has access to all of this design data at whatever level I wish to give him, whether it be just read-only permissions, read-write permissions, or some of the other areas of working with Fusion data. So very, very powerful tool. I think it's got some really, really clever tools. A lot of people have set up manual systems to do that in the background with tools like Vault and other data management systems. But basically, this is all live and it's all done for you. So we can quite easily and quickly be sharing that data and working with that as we go. So that's just one very basic area of collaborating with other users and sharing data across a CAD platform that that might allow us to work with that. So one of the other areas of Fusion 360, which also uses cloud computing, is what we commonly refer to as the shape generator. So this is a very interesting part of Fusion, and actually I've got this slide in the wrong order, I think, but basically with Fusion, if we model a bracket up, and I'm just going to jump forward. So this might have been a traditional sort of clevis bracket for attaching, say, a hydraulic cylinder arm to an excavator bucket or something like that. So if you had a hydraulic system that was using a hydraulic ram, basically this is how we might make up what we would call a standard sort of a clevis. Now, the concept with this is what we did at A2K was we ran this through a system called the shape generator. And what this does, it allows you to set up, as per that previous slide, this one here, some preserve zones. So if I was bolting this bracket down with 3 bolts, basically these red areas here represent that, effectively we can bolt that down to our plate or whatever it might be, preserve certain regions. We tell Fusion where the stress or the load for that particular part is. So again, on the particular clevis, obviously you would have a pin through this hole here that maybe takes, 100 Newton meters or whatever it might be, okay, as far as load is concerned. Now, what we do is we tell the system then that we're happy to preserve some of those areas, but basically what happens in between there is a bit irrelevant. Okay, so the connections between the 4 bolt down holes and the point for the retainer for the pin on the clevis can be whatever. And as you can see, this part of the model is a computer generated model that basically is defining the minimum amount of material we need to maintain the strength of 100 Newton meters. So what we did as a bit of a project, we actually printed this out in stainless steel on our 3D printer. As I said, we've been doing quite a bit of 3D printing, and this particular item here is physically a printed component. Now, we printed it in stainless steel. That was the material that we had in the machine at the time. And yeah, as you can see, that is a final printed object. But what the software actually does, it gives you 12 different iterations that you can choose from that would not compromise the strength of the part, but would give you multiple options and variations or iterations, we tend to call them. And I think we chose this one here and did some tidy up on it. So we actually just cleaned up some of the unnecessary material down here that we perhaps didn't need so much. And then, yeah, like I said, we can print that out and there's our completed component. Now, obviously, this type of design ingenuity has been used for many, many years in the aerospace industries, and NASA and the likes of Boeing and people like that have been using this at length for 20 plus years. Now, what brought this about, obviously, was this industrial revolution, where now we've got the option to have access to these cloud-based processing tools in very, very cheap software. So when Boeing started doing this, the software that they were using to do that, a product called CATIA, was a very expensive piece of software. And I mean, sort of in the order of $100,000 per seat of software. So very, very expensive software. But obviously with Fusion, and look, you can go and download a trial of Fusion tomorrow, a trial version of Fusion, and start doing this sort of thing. It's not rocket science anymore, so to speak, but yeah, very, very available to anybody that wants to get involved in these aspects of cloud computing. So yeah, quite a versatile and interesting aspect of the way engineering is moving forward. And look, like I said, because software has become so much more cloud orientated, anybody can basically do this. So the likes of General Motors now, for instance, are working on things like seatbelt brackets in their vehicles. So any product that needs to move, and I'm sure you've all heard the old formula of, you know, for every liter of fuel that a Boeing needs to get another kilo of product off the ground, needs another half a liter to get the liter of fuel off the ground. So it's one of those things that everybody is looking at now. Anything that is a component that moves, basically, it's great to be able to apply a lot of these principles to that. So here's a great example of a pressed metal bracket that General Motors had in one of their motor vehicles. And as you can see, holds the seatbelt bracket. What they did was they set up a 3D print type process for this. So rather than having 8 individual components, they reduced this down to one part. It's 40% lighter and 20% stronger. Now you're probably looking at that and going, well, yeah, but this is a very tricky part to create. Well, interestingly enough, now metal printing is becoming more of a thing, and we're finding more and more people are able to utilize this particular software and some of those tools. So again, here's those 12 iterations that, or in actual fact, this I think this one may have been done in Inventor, which gives you many, many more options to choose from. So you can see there a whole assortment of different iterations of your component based on that. So again, this is all the concepts of cloud computing that are allowing us to work with that. So basically, just to jump back into Fusion for 2 seconds, and before we wrap up today, really we wanted to talk a little bit about the collaboration side of sharing data and some of those tools. And there's quite a lot of other things in here that we could have talked about. But yeah, just to give you a bit of a rundown, if I was to go back into my assembly, under the design heading here, we've got this, what we call generative design. And this is the tool that's used to actually create those various iterations of a model. So you can see an example there of a caster or a little trolley wheel of some kind. And effectively the bracket that holds that to its mounting point has been put through a generative design or cloud manipulation tool. And basically we can force a server-based cloud system to allow us to work with that. So in there as well, we can do some rendering. So the rendering process can be sent up to the cloud. And for anybody that knows anything about rendering, rendering does chew up a lot of CPU. So basically, while you set a render going, sometimes you have to go and have a lunch break, or maybe even set this going last thing at night, so it runs overnight, so your CPU isn't chewed up while you're trying to do some other work. Good thing is with Fusion, we can send this up to a bank of Autodesk servers. Okay, and basically from there, we've got the option to have the render happen in the cloud. Okay, so there's quite a number of different functions that use a lot of the these cloud-based tools that are included with the Fusion software to allow us to work with that. Okay, so generative design is one of those, rendering is another. Animation actually is done locally, so this one won't so much use, basically it's for creating an exploded model of your assembly. An animation sequence is where we could simply pull our vise apart. And like I said, I have done other webinars based around the animation process, so you might like to look those up. Or certainly we can again send you some links, but the simulation mode where we can do things like stress analysis and FEA studies on a bracket or a component in certain conditions. So the Fusion tool again uses a cloud-based system. So the actual simulation process happens in 1/10 of the time that it would take your local, well, roughly, depends a little bit on your processor, obviously, but the simulation tools actually allow us to produce the result of the FEA study in 1/10 of the time. So yeah, if something was going to take 10 hours to process on your local machine, basically you can do it on the Autodesk servers in 1/10 of the processing time, because obviously they've got supercomputers that do this offline. So these are just the other modes that are available to us. As I mentioned before, this area here is a very interesting part of Fusion for creating CNC toolpaths. So you can see in there, we've got a process for creating some cutter paths for creating componentry. And this is all included if, like I said, really worthwhile, and I'd encourage you to download a copy of Fusion for free. Certainly there's 30-day free trials of that and other licenses, but the price point of the Fusion software is extremely cheap compared to some of the other software that we've had to work with over the last 10 or 15 years. So the whole concept is that Fusion is quite a collaborative tool. It allows us to manage all our data in the cloud. Having said that, if that's not your preference, we do have the option as well to come up here, and when we go to save our file, by default, it will save to the cloud. But if we go save as, we get an option here to save this to our local computer as well. Okay, so we can actually go out and save these files. If you don't want to save them to your cloud directory, you can certainly save them locally, and that way you can work with those files offline. So you're not locked in as such to being forced to work with the Internet of Things, as we call it, the IoT side of things, but we can actually save files locally to our local PC and work with them there. Okay, so if you're not particularly keen to work in a cloud-based system, we can certainly work with files locally. The other thing we can do as well is up here, we've got the option to work offline. So if you don't want, or you're not able to connect to the internet, if you're working in Outback Australia or a remote location where the internet is very flaky, we can simply work with our Fusion offline. And even if you were to set up a render process, what it does, it will store that render process and wait until you are connected to be able to use the online cloud system. So at the end of the day, guys, Fusion is an extremely powerful tool. It's got some really nice functionality for working with the cloud and being involved and collaborating with other users and working with aspects of the cloud space and functioning with that. So some very interesting things, and I hope you found it interesting what we've had to talk about today. But yeah, like I said, really clever from the concept of working with and managing your design history. So things like revisions and areas of that nature. Like I said, in here we can just simply click on a particular part and see when it was saved, who it was saved by, and numerous other elements in regard to working with your Fusion data and CAD information. So I hope you found today interesting. Like I said, we do these webinars quite frequently. So yeah, I will stay online for a moment just to take any questions. If you'd like to pop those into the chat window, I'll be more than happy to answer those for you. But if you'd like to have a look at some of our other webinars that will be coming up shortly, please go to the link you can see on your screen at the moment, and yeah, you'll be able to see the way we can go and view some of those other webinars. And also, if you'd like to get in touch with A2K Direct, feel free to use the email address you can see on your screen there, info@a2ktechnologies.com.au. We'd be more than happy to answer any of your questions. So yeah, there's a lot of benefit there, and I hope you found what we've had to say there valuable. Like I said, I will stay online for a few minutes. So thanks for your attention today and for attending today's webinar. It's been good to have you along, and hope everybody stays safe and well in these rather unusual and unprecedented times with COVID. But yeah. Thanks for your question there, Ben. Just having a quick read through that now, and I'll see if I can answer that for you with regard to linking an online file. Just give me 2 seconds to answer that. Yeah, that certainly is an option. So again, if I just jump back into Fusion there, if you want to, so as I mentioned, that email that Dexter received, if he was to click on the link that I sent him, I think your question, so you had a locally stored drawing that we could record the file path in a database and just click on a link to open it. So you're basically hyperlinking, I think, Ben. Certainly Fusion will happily do that in the Fusion space, yes. So we can, inside of Fusion 360, which is another interesting part of the whole system within so yeah, A360 or Fusion Drive, or I'll just see if I can jump into this and show you that. So yeah, we do have the option here under the Autodesk Drive system, and I would actually see all of the files in here under Autodesk Drive. But yes, you should be able to link, once this lets me in, I'll just sign into this quickly. And so I'm not sure if you've had a bit of a brief look at the concept of how the A360 system or the Autodesk Drive system works. But yes, we can link files. So you're looking at linking from a server, I guess, is what I'm understanding, or a file that's perhaps stored locally. And we can see in here, for instance, is where I would see the some of those files that I've got. But effectively in this particular area, we've got quite a lot of different elements and aspects. That in actual fact, I have done a webinar purely on the A360 system. So what I might do, Ben, is perhaps even send you a link to that particular webinar. But yes, I believe we can hyperlink effectively some of those files. And look, apologies for the challenge there with Dexter's microphone. It looks like he's had some voice issues there, but never mind. As I said, thanks for joining in today. It's been great to have you along, and yeah, we'll look forward to perhaps crossing paths down the track, or all the very best, and yeah, stay safe and well.